Welcome everyone to lesson 9. We are now moving strictly into solving territory again, this time with solving radical equations. We kind of dabbled a little bit with this at the end of lesson 8, but now we're going full force into solving radical equations. So there are a few different types of radical equations we're going to be solving. The first one is solve an equation with two radicals. So when you have an equation with the same radical equal to each other, the radicands, which remember, radicand is the inside stuff, they're equal to each other. So here, our first example, the square root of 5x minus 9 is equal to the square root of 3x plus 13. Since on both sides they're both square roots, we actually can drop the square roots and set the insides equal to each other. So here we're going to have 5x minus 9 is equal to 3x plus 13. Now we can solve. So the first thing we're going to do is subtract 3x from both sides. And we're going to be left with 2x minus 9 is equal to 13. Add 9 to both sides, and we have 2x is equal to 22. Divide by 2, and x is equal to 11. Even if your index number is larger than just a square root, here we have the fifth root of x minus 7 and the fifth root of 4x minus 22. Since they are both the fifth root, again, we just drop the roots and set the insides equal to each other. X minus 7 is equal to 4x minus 22. So I'm going to subtract x first from both sides. So minus 7 is equal to 3x minus 22. Add 22 to both sides. And we get 15 is equal to 3x. Divide by 3. And we get x is equal to 5. So that's what we need to do when we have the same radical on both sides. All right, the next concept is when we just have a single radical. So when you only have one radical in an equation, first you'll need to isolate it before taking the nth power, that should say power, not root, my apologies, of the radical, then solve for the variable. So this first one is actually a really nice example of this. So here we have the square root of 2x plus 5 is equal to 3. As you can see, 2x plus 5 is under the radical, so this radical is already isolated. So to start, square both sides. Take the power of 2 to each side. The square root and the square will cancel out. So we're left with 2x plus 5 is equal to 3 squared is 9. Now we just solve for x. Subtract 5. 2x is equal to 4. Divide by 2. X is equal to 2. All right, this next one. The fourth root of x minus 6 minus 13 is equal to negative 12. As you can see, the radical is not isolated. We have a minus 13. So we have to add 13 to both sides first. So the fourth root of x minus 6 is equal to 1. Now is when we do the fourth power. Fourth root and fourth power cancel out. So x minus 6 is equal to 1 to the fourth power, just stays 1. And now solve for x. Add 6 to both sides. And we get x is equal to 7. All right, our next one, again, we see we have a minus 17 after the radical, so we have to start with adding 17 to both sides. So we have the square root of 3x plus 40 is equal to 5. This is a square root, so we square both sides to get rid of the root. So 3x plus 40 is equal to 25. Subtract 40 from each side. So 3x is equal to negative 15. Divide both sides by 3. And we get x is equal to negative 5. All right, cube root of 2x plus 54 plus 12 is equal to 20. So we start, we have to subtract 12 from both sides. So the cube root of 2x plus 54 is equal to 8. Take both sides to the third power to cancel out our radical. We have 2x plus 54 is equal to 512. Subtract 54 from both sides. And we get 2x is equal to 458. Divide by 2. And we get x equals 229. So there we go. So that is when we have a single radical. All right, now we need to take a look at what are called extraneous solutions. So an extraneous solution is a solution that we get from a problem, but when we go back and check the answer, it fails. Therefore, the answer is not a valid answer. This means in these next few problems, you will be checking your answers. Now, to do these next problems we're going to do, we have to remember some first semester stuff. The first is multiplying binomials. You're originally going to have it start out as something like this, x plus 4 squared. But remember, when you have something squared, it's being multiplied by itself. So x plus 4 squared is x plus 4 times x plus 4. I'm going to use distribution here. Everything from the first gets multiplied to everything in the second. So x times x is x squared. X times 4 is plus 4x. 4 times x is 4x. And then 4 times 4 is 16. Finally, combine like terms in the middle. And we have x squared plus 8x plus 16. So that's the first thing we need to remember. The second thing we need to remember is solving quadratics by factoring when a is equal to 1. So we are keeping these problems super nice. Super, super nice. You don't have to use the quadratic formula if you don't want to. It's not a not equal to 1 factoring. It's just simple a is equal to 1. So here we have x squared minus 11x plus 18. Remember, factors of c that give us b. So our c value is 18. So we need to list out the factors of 18. 1 and 18, 2 and 9, 3 and 6. Then we want the pair that gives us negative 11. So the only pair that will give us negative 11 is 2 and 9, but wait, both will have a negative on it. So then we write our factors. X minus 2 and x minus 9 is equal to 0. And then, super easy to solve for x, take the opposite. Opposite of negative 2 is positive 2. Opposite of minus 9 is positive 9. So there you have it, refreshing ourselves on factoring quadratics when a is equal to 1. So in the next video, we're going to take a look at these extraneous solution problems.